Yeah, I'm a biomedical neuroscientist working for NASA, so I am going to tell you what I
Indeed,
I
no.
am going to tell you
Indeed.
because I know what I'm talking
In
about.
that case,
Would you at least consider this? If what we're telling you is true, would you consider this? Because it makes evolution really impossible.
Yeah, I mean, I think it's definitely going to make me question a lot of things.
We're going through this right on the back here. What percent difference are we from ape-like creatures? So they used to say 4 to 5%. Back then, they even earlier than that, they thought we were only 2% different. Then they said only 1% different before that. So we're going to go with an easy number, 1%. See, we're actually really similar, even though it's actually more than 15, to make it easy for evolution. Well, how many genetic base pairs are in the human DNA? Any idea?
3 billion.
Yeah, that's the old number. 4.5 is what we know now. 4.5 billion base pairs that make you you. We're going to go with the old number 3 billion to make it easier. Well, if we're 1% different from ape-like creatures, even though we know it's 15, if we went with 1%, well, how many differences, how many positive, beneficial mutations in our base pairs need to take place in order to go from ape-like creature to a human? It's there on your sheet. How many?
Saying 670.
Oh, no, not quite there yet. Number 3. Number 3.
30.
30 million is 1% of 3 billion. So you'd have to have 30 million positive beneficial changes to go from one kind of animal, or from an ape-like creature, to a human being. Okay? How long would that take? This is where we go to step 4, 5, 6, and 7.
How accurate like our population estimates are from creatures at that time?
Yeah, they would go based on a population of 100,000. They have it all the way up to 1 million. So it varies, and that determines, but I'm going to make it even easier than they say. They say in a human population within a local thing, 30 years, but really realistically to reach the entire, if you had a beneficial mutation, forgive me, what was your first name? Patrick, I'm sorry. I was talking to Nick and I thought it was going to be Nick. Patrick, if you had a beneficial mutation and that mutation needed to take over the population, how many generations, first of all, what would it take to do that? And how many generations would it take to do that?
I couldn't tell you the numbers.
Well, what it would take is your offspring with the beneficial mutation would have to survive. All of us and our offspring would have to die because we don't have it. That way your beneficial mutation becomes what we call fixed in the environment, right? So how many generations would it take? Evolutionary scientists say about 300 generations to get one beneficial mutation fixed in the environment.
Okay.
We're not going to go with 300 generations. We're going to go with every generation. Every single generation, you have a beneficial mutation fixed in the environment, which is being very kind to evolution.
Couldn't you have multiple though in the same generation? Multiple mutations? I mean, if they're dying and it makes it more likely, wouldn't it be pretty like...
Multiple happening at the same time. Do we see that happening? No. Could you assume that it happened? You can assume anything you want, but now you're outside the realm of science. Scientifically, even to say one beneficial mutation every generation is being extremely nice, extremely generous. So I'd say you got to go with what I got here. You feel free to look it up. Actually, on the back, I got a QR code. I got a whole show that goes through all the data on this, the references and everything. So one beneficial mutation every generation. How long until you have kids? How long is every generation?
Oh, like 20, 25 years?
Yeah, we're going to go with the lowest number, 20. Every 20 years, we have a new generation, okay? So that means every 20 years, we have one beneficial mutation fixed in the environment, okay? Under those conditions, how long would it take to get the 30 million beneficial mutations that we need?
Wait, can I just say this is flawed?
Go ahead. Yeah, well,
Yeah, like, okay,
tell me the argument on why it's flawed.
okay, first of all, this doesn't account for the fact that one, natural selection. So you're talking about beneficial mutations as if you can individually cause like some point mutation and cause one genetic sequence to change, but that's not how genetics works. How it works is you have these multitude of, you had mentioned before, these multitude of mutations, and beneficial or not beneficial is that word shouldn't really exist when you think of gene characters and what they can do intracellularly because they're different adaptational responses. So
You know why? Because normally what we see is not beneficial mutations. Normally we see harmful mutations that need corrected. I'm ignoring all those. I'm actually doing you a favor and ignoring all those.
Regarding polymorphisms or any type of just non-damaging types of mutation, which are neither beneficial or damaging, they can.
I'm actually making it easier than that. I'm saying forget all the.
I know, but
forget all the neutral. Okay, all the neutral mutations happen. That's fine. But I'm talking about just the beneficial ones, because to go from an ape-like creature to a human,
But what classifies as beneficial? Because
here's what class. Okay, that's a term the evolutionists have come up with. They're the ones who've said a beneficial mutation. So I'm using their terminology.
their classification.
I'll tell you, going from anything that takes me from this ape-like creature to a human being, I'm going to call that beneficial mutation.
Yeah,
Does that
but
make sense?
But that doesn't really. Do you see how when you characterize that, does it make sense? Because a monkey, we talk about ape-like creatures. Okay, they have a large appendices to hang from trees. Evolutionary, that is a benefit to them. Whereas for us, we don't need those features, and that is these benefited mutations are only when you create this barrier. Okay, this is beneficial, but okay, it's beneficial under these circumstances. So and that.
So do you agree? Do you believe that we evolved from ape-like ancestors?
Yes.
Would you agree that every single evolutionary stage along the way that went from an ape-like creature to a human was a beneficial mutation?
No.
No, I'm saying eventually we're here, humans are here. There was ape-like ancestors. So there had to be at least some series of mutations to go from an ape-like creature to a human. Some series of mutations. A lot of bad, a lot of different directions. I'm ignoring all the other directions, and I'm saying straight line, man. We need 30 million genetic changes to go from an ape-like creature to a human. Would you agree with that?
Okay, well, so my question would be, how many mutations occurs from one offspring to another? How many mutations are occurring between the offspring?
And it's not near one beneficial mutation every 20 years. I'm giving you one beneficial mutation every 20 years. Let me finish the numbers, and then you keep bringing the arguments, and John and I will talk to you about that. Let me finish the argument here real quick. So we know that we're giving it 1% different from ape-like creatures. There's 3 billion base pairs. That's 30 million genetic changes that need to happen, and I'm calling those beneficial mutations that have to be fixed in the population. How long would that take to occur? And by the way, this argument, I know you're arguing against it, this was developed by an evolutionary geneticist. He said, we got a big problem here. His name was Haldane. He's like, we're screwed. We don't have enough time to make this happen. Because if we gave one beneficial mutation fixed in the population every 20 years, every generation, all you have to do is say, I need 30 million of them. 30 million times 20 years, I need 600 million years to go from an ape-like creature to a human being. And that's ignoring all the bad mutations. That's only the good. That's making it actually a miracle. I'm giving you a miracle, and it still can't happen.
So,
what do you think? Let me finish. I'm trying to talk to one at a time since we're filming this. Did you have any questions on that, or do you want to let him ask questions?
Oh, you can ask questions.
Okay, come on. I'll step right up here to the mic then and ask your questions.
okay, yeah.
All right, go ahead and ask your questions.
You had detailed again about the beneficial mutation, and could you go over what you had previously said just a second ago?
Yeah, we're saying that if we give evolution a really good shot, and we give it the best case scenario, and we have one beneficial mutation every single generation, which does not happen, that's being kind evolution. They would say it takes on average 300 generations for a beneficial mutation to be fixed, to take over the population. What was your name?
Luis.
Luis, if you had a beneficial mutation that we all could use, there's no way we can get it. The only way to populate the world with your beneficial mutation is for you to start having kids.
Well, no, there's a 50%, or if you look at the genetic tree, or just Mendel's laws, right? You do the Punnett squares, depending on how complex and the alleles and stuff, there's a 25% chance or 50% chance. Depending if you're going to be dominant or recessive for that beneficial.
That makes it worse. I'm making it easy. I'm saying every generation it guarantees to be passed on. So I'm making it even easier. That makes it harder. That would make it take even longer.
Yeah, okay. So
okay.
It wouldn't just be one, if under your thing where every offspring produces a new genetic, this beneficial mutation, then once again, these aren't single point mutations that occurs during development. These are a multitude of genetic sequences, in almost every cell and every to say one beneficial mutation once again there's thousands, if not millions, of mutations that occur.
How many of them are beneficial?
But it doesn't need to be beneficial for evolution to occur. You know what I'm saying?
But what takes us from an ape-like creature to a human are going to be the beneficial ones.
It's going to be what adopt us in our environment.
Which we call beneficial mutations.
Okay.
So you agree with me?
So, okay, if you want to classify human-like features as beneficial mutations, then sure, okay, yes.
So anything that takes you from A to B, it has to be beneficial. Otherwise, natural selection will select it out. You understand that, right?
Okay.
Neo-Darwinism is the whole idea that through mutations and a natural selection, things go from good to better. So it's good of you to ask those questions, because we're just going to tell you what John Haldane came up with. So I'm going to tell you what he was doing. He wasn't saying what you just thought he was saying, which was, surely, look, everybody gets mutations and it's a parallel process that everybody gets. That's not what he was saying. He's saying it doesn't matter how many everybody gets. What we need to do is fix a beneficial mutation in the population for the population to go further and advance. So it's okay. You can ask me all the questions in just a second. So Neo-Darwinism is saying that we need something that takes us from A to B, and natural selection is going to help us get there. This is fine. And we're saying we're going to stick with that. Now, Haldane was saying that it will take you a certain number of generations that gives you one beneficial mutation. And we haven't even said what John Haldane said. If we tell you what John Haldane said, your mind will explode. You walk away from here thinking that he just made things up. But he was the biggest and the most popular scientist that he was ever known. He was the Einstein of his time. Everybody thought that he was the cleverest person who ever lived when it comes to genetics.
Talks about him as the best of the best in his field.
Yeah, do a search on John Haldane, and you'll find out that this is no ordinary guy. This is not like we guys are sitting here telling you this stuff. If this was our research, you can stand here and say whatever you want. So whatever you're doing, you're disagreeing with John Haldane. Moto Kimura came along, who's Japanese, the second most popular geneticist in the world, that agreed with John Haldane. And that's why he came up with another theory to solve the problem. Here's the deal. We're trying to educate people. We're trying to tell them, look, there is something you haven't known since 1957, and no biology professor tells you, no scientist tells you, and nobody's telling anybody anything. Yet we find loads of people who suddenly become experts in this, who want to tell us that what we're telling them is wrong.
First of all, I'm a biomedical neuroscientist working for NASA, so I am going to tell you what I am going to tell you, because I know what I'm talking about.
In that case, we want to share with you what the facts are, and I want you to see them. We want to see these facts. So this is what Haldane said. Haldane said it takes, and I'm going to show you the quote in a minute. Haldane said it takes 300 generations for one beneficial mutation to come along.
In what organism?
But oh no,
that's not true at all.
That's not what he said. He said he did it on cattle, he did it on animal, he did it on vertebrates, and he even did it on flowers. He even did it on everything. So if you don't believe me, go into ChatGPT that can do the analysis for you, and you'll see all the results.
So for example, right? Let's say father is 6'3", mother is 5'6".
Yes.
Child is now 6 foot.
Yes. That's not a genetic.
That is
not
a
a
beneficial
mutation.
mutation.
No,
right? Because we're talking. Let's go take it a step further. If they're 4 feet, now they're 5 feet. They're getting towards a step to beneficial mutations. That extra foot of height they gained is how many base pairs of DNA mutations that occurred that isn't consistent with this one beneficial mutation.
What's your name again?
Luis.
Luis, yes. Luis. In genetics, I'm surprised you said that. In genetics, genetic diversity is part of the DNA, which means that the word mutation has a certain meaning. And in fact, I'll show you what they are, and these are the different types of.
Well, I'm aware.
Yeah, I know you're saying you're aware of it, but what you're saying is not a mutation. A mutation, you're describing a mutation, a change in allele. We're not saying that.
What I'm describing is natural selection, though, because that's how natural selection works. If you have the genome, if you have the height of the genes for 6'4",
and we don't disagree with that.
Exactly. So that is natural selection. That is the.
Yeah, we don't disagree with natural selection. We're not saying natural selection.
But natural selection is the pivotal point for evolution.
Yeah, we don't disagree.
And we're saying, based on that, it would take 600 million years to go from an ape-like creature to a human.
We don't disagree.
So if you agree with my statement, but then you agree, though, that how many mutations occur, how many different rearrangement occurs during that offspring, there's going to be more than one beneficial mutation. I could understand one beneficial mutation in 300 years if they did this experiment in some viruses in a tube. I have read and seen experiences like that, but.
So you give me the number. How many beneficial mutations? I've given you one beneficial mutation every single generation, and I've done that fixed throughout the entire population, which is impossible. How many would you like to have?
How many
beneficial mutations would you like to have?
From an ape to a human?
Every single generation. Every single generation, a beneficial mutation. How many would you like to have?
Well, I'd like to think they work in kind of like in I wouldn't want to say the word exponential, but kind of in a feed forward like mechanism where once.
Sorry, I would call it exponential. You know, white rabbits and then the snow melts and then they're still white and it's all brown, they die, that will exponentially increase how fast all of the rabbits turn white because they will die very fast.
They will die very fast.
Yeah, he
The
brought up a
rabbits
good
in
point though.
the brown environment, so they're gonna figure that shit out. Like we gotta change color.
Okay. But they don't decide, I want to change color and therefore change color. That's not how it works.
No, the ones
Epigenetics.
who happen to have that do.
Actually, epigenetics are playing more of a role than we ever thought before. Genetically, we realize there's a software, what they used to think was junk DNA. That's actually the software telling the hardware what to do, telling it what color fur to have, what color fur should my babies have. And you can actually go from one to the other, and it's not changing the genetics. That's built into the genetics.
I said like they'll figure it out, but I meant like natural selection will henceforth figure it out for them. Like the ones who will live will be brown, but that would exponentially increase the rates compared to this like purely just genetic math. They're henceforth, you guys are kind of forgetting the environment. I haven't heard that brought up. The environments in which they
Again,
produce.
you look at these numbers, we're being very kind actually. We're making it easier for evolution and showing even as easy it is, making it this easy, it's still impossible.
Right, if you're just looking at it, these people mate, chance of mutation, they keep mating, but the environment is shaping that, and that's
Yes.
what Darwin found out in the
No, that's perfect. Look, listen, everything you're saying, you're describing things we wouldn't disagree with. We're not talking about how the environment works and how natural selection works. Nobody's denying that. Some people might have issues with that. That's not us. We're explaining to you that what is required for natural selection to work is that you need mutations, not just simply a variation within a kind. So genetic diversity already exists. If you don't have a single mutation, you are definitely going to get a variety in the environment. Right now, if I have children, they're going to be different to me. They're going to be either taller or shorter. It doesn't mean I had a mutation. It just means part of my genetics. In fact, it's been calculated that DNA, you can create this many varieties, 10 to the power of 1012. That is a lot of variation. That's more than atoms in the universe.
Without mutations. That's
Without
just
mutations.
the variations.
So we're saying this is not what makes an ape-like creature become a human. According to John Haldane, according to Mota Kimura, according to all the scientists that came afterwards, and I can name them for you one by one, they all were struggling with the idea that it is mutations that make something different than its own kind. You need those errors, and they have to be beneficial in order for it to work. John Haldane was the only guy who said, okay, I'm going to work it out. I can show you the quotes. He worked it out. He said, 10,000 loci will take 300,000 generations. That was a killer for him. He spent the rest of his life trying to reconcile it, and he couldn't. Somebody came afterwards and he said, that's a Haldane's dilemma. And in 1968, we're talking like 11 years later, a guy comes along and he says, oh, you're right. This doesn't work. Let's come up with a completely new theory.
That's kind of okay. That's kind of flawed, though. You talk about 1957. One, how many studies and how many?
The last one?
Yeah, how many studies has this been?
2019.
No, how many studies have been gone to support this? One.
You want to see
we
them?
have in the scientific community.
You want to see the studies that come before it? Okay. Now here's the problem. It's good for you to ask those questions, and we want to encourage you.
Right, because you're basing this whole argument off of
Yeah.
one paper.
No. We love
one
you.
Paper, right?
We love you.
That's-
So here we go. Look. So you want to know all the papers that came along? This is only a snapshot of some of the papers, which absolutely is mind-blowing to see how many people were discussing this. I'll bring you those, and I'll even send them to you because I've got them all. So the problem is that these are the scientists who've already been talking about it. Here we go. Look. Look how many scientists have been discussing it. Okay. So it's not a new thing. Our gripe is that nobody knows about it. And we want to show it to you so that your eyes will open up, so you do better medicine, so you do better science, you learn more things and you grow. What we want is students to come here and ask good questions and say, yeah, I can see there's a problem. Let's discuss A and B and C, rather than say, no, it doesn't work because A and B. Because when you say, no, it doesn't work, you're not disagreeing with John or Eric. You're disagreeing with these guys.
I will. Okay, but we disagree with maybe a handful of 10, 15, but then there's also a multitude of 200, 300 respected scientists that are also opposing this. So you make it seem like-
it still a Haldane's dilemma then? Why is it still a dilemma?
But it's not a dilemma. We're being taught in institutions.
You said it's not a dilemma.
Have you studied this thing?
Have you you don't
How
This-
do you
this
know, how do you
specific-
know it's not a dilemma?
Yeah, how do you know?
This seems like
I
a
mean,
little
how do we
plan.
know at that point? At that point, how do we know anything? What's 2 + 2? Why is there
That's
math?
a philosophical question. We're talking about
But that is
science.
I'm
not
talking about, do
philosophical.
you actually know that Haldane's dilemma has been solved? Because you came here not knowing much about it. You've asked a lot of questions, and now you're saying, no, everybody disagrees.
What I'm
with
trying
it.
to say is that you're handpicking a certain few articles, and then you're forgetting it seems like what I'm trying to say is that you're basing your research, you're basing what you're saying. Okay. Yes, it seems like.
Right. You don't know that.
Yes, because I am observing and I'm telling you what it seems like to me, my perspective. That's what it means to be, it seems like. So to me, it seems like you're basing your argument off of these select few articles.
And that's based on how much research have you done on this?
A lot. I work in the radiation biophysics.
On this argument?
On this argument, no.
Okay,
So when it seems like we're handpicking, even though you've done no research.
So Lewis, imagine I'm a imagine I'm a professor in your school, and I come along. And I say, hey guys, did you know that this thing is a thing and has been around?
I'm not
for
acknowledging
a while?
that
Would
it's
you
not
stand
a
up
thing
and say, no, it can't be a thing because everybody else thinks otherwise?
I'm not acknowledging that it's not a thing. I'm not
you.
saying that there is not this refuting argument. What I'm trying to say is in the scientific community, there is a large hole of agreement that, okay, Darwinism, natural selection, macroevolution is real and occurs through these mechanisms.
Oh, we don't disagree with
adaptation,
natural selection.
Well, no, he said macro, not microevolution.
Did you say macro?
Yeah,
If
macroevolution.
if you can bring me, we'll be here today and we're going to be tomorrow in front of the student union. I got $1,000 if you can bring me the macroevolution proof. Not micro, not variation, macro. You bring me that proof, I'll give you $1,000.
And you know what? It will be really nice
I'll just
for
show
people.
it, just so that
you
you're
know,
like,
to see it.
just to make you want to grab it.
We're
right?
frustrated because we don't have anybody coming to us and saying, I know this stuff and I know how it works. Everybody's coming up with, I have an opinion about this stuff.
I know how it works at a genetic level. If you want, I could describe the whole
Well,
process.
in that case, you would have no problems with John Haldane.
Yeah, and
because
that is why I have a problem, though, right? Because
But you just said you haven't researched this.
No, but I don't need to research. Okay, he's talking about point mutations, single genetic beneficial mutations. I don't need to study the specific person's view to understand how genetics works. Do you understand that? So understanding my
how
foundation.
do we learn stuff? When you do a research, you read people's papers, don't you?
No, like yes and no,
You're
right?
not
Because
gonna go into
they're
DNA
yes
checker.
and no, because for example, like there are a multitude of peer-reviewed articles that are not true. And that's why replication is very important,
interesting.
right?
That is very
That's very because there are a lot of peer-reviewed articles that are not true, which tells us a whole lot right there.
No, it does 100%. I'm like, that's not. I'm going to argue. That's a problem in our scientific community.
Absolutely.
But I don't want to
agree
deter
again.
from the point of what we're talking about here, which is this macroevolution and this guy who he says it's not possible for these beneficial mutations, but.
No, he said
To
it's
me, it
possible.
sounds like you guys.
No, he said it's possible.
Macroevolution is possible.
The guy who invented this.
Macroevolution is possible?
That's what the guy
That's
who
what
invented
the
this
guy
said. He said
believes it.
macroevolution is possible.
He believes it.
But he said, I can't fit it in the time frame. Because I got 600 million years to get 30 million mutations. It doesn't work.
Yeah, but this is a 1957.
Macroevolution is possible?
This guy believed
That
it.
guy did.
And that's why he did the research. So he did
But
the
he
research.
never did solve his dilemma.
So the best guy you can imagine doing a research on DNA is the guy who did it. The Einstein of that age came along and he said, I know a lot. Everybody agreed he knows a lot. Everybody said he's the most clever person in the world. And he said, great, don't worry. Look, I'm going to find out how long it takes for, look, this is the quote, proposed by genetics JBS Haldane. The dilemma centers a question of how long would it take for beneficial mutations to be fixed, and this is a technical term, spread through the population in a species through natural selection. He was agreeing that it works, just like you, all of you agree.
We couldn't fit the time.
And he said, look, I'm going to work it out. And this is what he discovered. I'm going to show it to you because I want you guys to, we are here to help you understand genetics, hopefully better than you've ever had it before. So this guy came up with that it would take 300 generations to have one beneficial mutation. And therefore, when you do the math, did you get as far as 1,667?
I did not know.
Okay, so he came up with 1,667 if we have 10 million years for this ape-like creature to become a human being, which clearly is not possible. So it became known as Haldane's dilemma. Now tell me something. Why would they hide that from students? Just tell me. Why would you think they would not bring it up? What are the reasons why this Einstein of a geneticist will come up with something that nobody brings up and lets people know? Why do you think that would be?
I believe Eric earlier said it would disgrace the image of God.
No, it's because they had such a bias, because this guy still died in evolution. It'll be like Lewis here. No matter what I tell him, he will die and live on that mountain. He will not change his mind. This is the same guy. This guy did the same. He died an evolutionist. And everybody went into panic because nobody knew how to solve it. A guy from Japan came. Yes. With a guy called, what's his name? Mota. No, it's not sold.
It's not
Give
sold.
me the name of the paper. Give me the name of the paper. We're not standing here not knowing that the whole story of genetics here.
Well, here, the Canadian Science and Publishing.
Yes.
Right here, it talks about it right here.
Yes. What's the name of the publication that solved the dilemma?
Canadian Science Publication.
Yes, that's not.
What's
that's,
the name of the
that's
paper?
The paper. The name of who wrote the paper.
Okay, Sex Solves Haldane's Dilemma.
So what's that? Sex? Exactly. Here we go. Okay. Do you want me to show you what he did? I'm going to show it to you here. And so did Moto Komura, by the
Are
way.
you familiar with genetic recombination?
Yes, of course I am. We all know.
The mechanism?
Yeah, sure. I'm going to show it to you because I don't want people to think that we're not done our homework here. There we go. Look. Sex solves Haldane's dilemma. And this is what he came up with. The reason was that Haldane's model did not include recombination, right? That is the reason why he thought that. And you know what's embarrassing about that? His paper spoke about recombination all the way through it. And I'm going to show it to you. So this guy came along. Look, in 2019. Yes, when you take two alleles and it combines them together, and it's a repair mechanism. And if you want to see all the other repair mechanisms, I'll show you. I'm going to show you. I'm going to show you. I'm going to show you all the repair. I'm going to show you all the repair mechanisms here. Parallel process. There we go, by the way. He's done all the population. This is his paper, in case you're interested. Hang on. I've got to find the repair mechanism.
And you believe this guy? Right? That we're going with what he said?
We have to believe him.
Well, I think God has given us all minds to think, and we need to take. If somebody says something that's true, we should fix our mind on it. And if it's not true, we should reject it. And that's why you're examining what we're saying, and you're deciding how much of this do I believe is true, and how much do I believe is false. So I think that's exactly what we're all supposed to be doing. So I'm going through the science, going, it's impossible. Louis, you got to go.
Can I show you something impressive,
Hey,
though?
would you at least consider this? If what we're telling you is true, would you consider this? Because it makes evolution really impossible.
Yeah, I mean, I think it's definitely going to make me question a lot of things.
Good.
That's what science should do, so.
Good.
Here, look. There we go. All the repair mechanisms. Here's a shorter version of it. Well, that would be that one. Look, this is. All right. Here's one. These are all the repair mechanisms, and recombination is one of them. But if you want to see all of them.
Yeah. Sorry, madam.
Oh man, look, it's not working. Oh, there you go. Maybe it's just the repair mechanisms. We know. Look, and parallel process. We're all.
Need to look at repair mechanisms.
You know about them. Louis, you know what hurts my feelings more than anything else? An intelligent man like you who knows about genetics, obviously, rather than say, I'll check it out, because you shouldn't be biased, should we? Yes. Tell me something. You think scientists should be biased towards one view and not examine all the views?
In this case, there is a lot of evidence arguing against you. I think you have a niche viewpoint.
You said there's a lot of argument against it. There are two people. One, Moto Komura, who came up with the neutral theory of evolution, and the second one, Louis, please pay attention, is sex will solve the problem, and both of them were flawed. One of them creates error catastrophe, and he didn't even tell you. You know what error catastrophe is? Error catastrophe, yeah. Do you know what that is? It's when in every generation you get a harmful fixed mutation. That means the population is going to die. It's called error catastrophe. He created one that's 16,400% more than the population would go through. So, now, tell me something. Louis, put it here, man.
Yeah, and hey, you guys have.
If you need, look, can I do one more thing? If you have any more questions, you promise to come back and ask.
Yeah, I mean, I'll probably come back afterwards. I'm probably going to look into what she said.
And if you have anything, you come back. Okay, you promise me. Okay, we do this because we care.
Yeah, I mean, I think it's a good exercise.
Good.